Alright, so welcome to our virtual lecture today, and so we're going to talk about integration by substitution. So we're going to look at expressions like this. Integration by substitution is basically undoing what chain rule would do to take the derivative. So it's the opposite to chain rule. So for example, if you have this expression right here, you could integrate it by firstly expanding this cube, then distributing this to x, and you would then have a polynomial that you could integrate, but that is extremely slow and is not the best way to do it. So what we're going to do instead is, notice that some random circle appeared here. I had to delete it. What we're going to do is we're going to notice that this expression right here, if you inside of the parentheses, if you take the derivative, you get this expression right here. So we're going to use that to solve our integral. So we're going to introduce a new variable, u, and we're going to let it be x squared minus 9. So when we calculate the differential, notice that I have dx here. That's not going to work. I need a du. So to calculate that differential, I take the derivative of the polynomial, in this case 2x, and then multiply it times the differential of x. So let's look at what I have. Let's use some colors. So for example, this in yellow is going to be u. This in green is going to be du. So my integral becomes, well, when I substitute the yellow, I get u that is still cubed, so u cubed, and then I get the green, which is du. Now this integral is easy to calculate. You just do the power rule. So you do u to the power of 3 plus 1, that is 4, divided by 4, plus c. But nobody asked you about the integral with respect to u, so you take back your substitution and write it in terms of x. So you get x squared minus 9 instead of u to the 4th over 4 plus c. And that's going to be your answer. That's your antiderivative. And you can check that if you take the derivative of this expression using chain rule, you get the expression inside of the antiderivative. So that is how you undo the chain rule. So now let's move to the next one. So this one, we don't have exactly the derivative of x cubed plus 5 outside, but close enough because the derivative of x cubed plus 5 is going to give you 3x squared, and then you have an x squared here, so that substitution may in fact work. So let's check that. So let's take u to be the inside of this parenthesis. Now I have dx. I don't care about dx. I want du. So I'm going to write du is going to be the derivative of this expression, which is 3x squared dx. Now, let's take a look with colors. What do we have? I have here x squared dx, and I have here x squared dx. So it seems like I have to do something with this 3, and we will in 1 second. Now, here, inside of the parentheses, I have my u. That's how I chose it. So it looks like I have a u to the 4th, and I have to do something about this one. So since I don't have any 3's in my original expression, and I only have x squared dx, I'm going to divide this 3, or multiply it times 1/3 if you want, and get rid of it, so that now I have exactly what I have in green on my left hand side, so I can substitute it directly into the integral. So what do I do? Well, x squared dx, which is what I have in green, becomes 1/3 of du. And what I have in yellow is just u to the 4th. So that's my integral. So I have to make sure that I take everything inside of the integral. I cannot leave an x floating around and not take care of it. That wouldn't work. So I'm not trying to disappear things and make things disappear or anything like that. I'm trying to take everything in there and substitute it with something. And once I do that, I can just go ahead and take the antiderivative by using the power rule in this case. So a third of u to the fifth, 4 plus 1, right, over 5 plus c. And that gives us 1/15 of, let's take back our substitution. Instead of u, I'm going to write x cubed plus 5 to the power of 5 plus c. And that is going to be my answer. Alright, so let's keep going. Let's make things a little more complicated. No clicker questions today, of course, because we're not in class. Let's leave it there. Sorry for all the scrolling. So this one, what do we have? Well, notice the denominator, 1 plus x to the fourth. Ignore the square for the moment. The derivative of that is going to give us 4x cubed, which looks like what I have here of maybe by the 1/4 or the 4, so that's not a problem, as we saw in the previous example. So let's call this thing u. U is going to be 1 plus x to the fourth. Now, why do I not grab the square? Well, because if I had to take, once I take the derivative, I would have a 2 times 1 plus x to the fourth times the derivative of the inside, so that's not what I want. So I need, or the reason why I do this is because I need an x cubed, and this is going to give it to me because I take the derivative and I get 4x cubed dx. And now let's use some other colors to not get boring. I have x cubed dx. So that 4, I need to do something about it. And now this, you can see that's straight up u, so there's no problem already. So let's fix the problem with the 4, and to do that I just multiply times 1/4 on both sides, and I get exactly what I want, which in this case is x cubed dx. So I can substitute that x cubed dx by 1/4 of du. Maybe I gave myself too little room there, so let's increase the du, the room. And now I have, what do I have? Well, I'm left with the fraction 1 over u squared. So you can treat that as u to -2 and use your power rule as before. And that's going to be plus 1, so it gives me u to -1 over -1 times 4, so -4 plus c. And that's going to become -1 over, I'm going to put this u down here for u, and I pull the negative outside. And I take back my substitution. Let's make a little box here for my substitution so I can keep writing down here. -1 over 4 times 1 plus x to the fourth plus c. Okay. And that's your answer. Should have marked it. And alright, so let me stop here so I can put it on YouTube and I don't have to have any problems with the size of the video. I'm going to continue with a part 2 that is going to be linked below. Alright, that's that for this one.